Artemis I. This was the spectacular, uncrewed dress rehearsal for the entire program. Launched in November 2022, Artemis I was the first ever all-up test flight of the Space Launch System, the most powerful rocket NASA has ever launched, and the Orion spacecraft. The mission's primary goal was to prove the hardware could do its job before any astronauts climbed aboard. The Orion spacecraft traveled almost 270,000 miles from Earth, flying farther than any human-rated spacecraft in history. After entering a distant orbit around the Moon, it returned to Earth, ending with a crucial, high-speed re-entry to test its heat shield. The mission met its primary objectives and returned critical performance data, including heat shield data that NASA later used to adjust plans for the first crewed flight. Artemis II. This will be the first time in over 50 years that humans will fly to the vicinity of the Moon. Artemis II is the first crewed flight of the program, carrying a 4-person crew inside the Orion capsule. The mission is not a landing. It's a roughly 10-day free return lunar flyby, a crewed trip to the Moon's vicinity, but without entering lunar orbit. The primary objective is to test all of Orion's life support, communication, and navigation systems, with a human crew on board for a deep space mission. It will be the final, full-scale shakedown to verify that the vehicle is safe and ready to support a landing mission. Artemis III. This is the historic mission that will land humans back on the lunar surface. Artemis III will see a crew of 4 travel to lunar orbit in the Orion capsule. From there, 2 astronauts will transfer to the human landing system. For Artemis III, that lander is planned to be SpaceX's Starship HLS. They will descend to the surface and land in the Moon's south polar region, an area unexplored by humans and believed to be rich in water ice. The mission will achieve a landmark goal to land the first woman and the first person of color on the Moon, where they will conduct scientific research and technology demonstrations. Artemis IV. This mission marks the beginning of the program's sustainable phase, with the focus shifting to building long-term infrastructure. Artemis IV will be the first mission to use an upgraded, more powerful version of the SLS rocket. Its crew will deliver the International Habitation Module, or IHAB, to the Lunar Gateway, a small minimalist space station that will be assembled in orbit around the Moon. After docking with and helping to activate the gateway, a crew will once again descend to the lunar surface. This mission will prove the gateway's role as a vital staging point and command center for regular lunar missions. Artemis V. This mission will significantly enhance the capabilities of the Lunar Gateway and the mobility of astronauts on the surface. Its primary co-manifested delivery is ESA's Lunar View Module, formerly associated with Esprit refueling plans, which adds propellant logistics capability and a major windowed element for Gateway. NASA's published Artemis V objectives focus on integrating Lunar View with Gateway and completing a crewed lunar surface expedition using an HLS. The exact flight assignment for specific surface vehicles can shift as hardware matures. Artemis VI. Artemis VI's published objectives are to integrate the crew and science airlock with Gateway and complete the 4th crewed lunar surface expedition. The crewed Orion spacecraft is planned to deliver the crew and science airlock to Gateway, enabling transfers for crew and payloads between Gateway's interior and open space. NASA has not published a mission-specific surface timeline like a multi-day rover traverse for Artemis VI. What's public is the Gateway assembly milestone, and that the crew will conduct a lunar surface expedition using an HLS. By this point, Gateway is intended to function as a true staging node, a place to dock, transfer crew, and prepare landers and payloads between Earth and the lunar surface. Artemis VII. NASA has not published an official mission-numbered plan that Artemis VII is the start of a permanent outpost. The Artemis Base Camp idea is a longer-term concept for later sustained surface operations. NASA has not publicly assigned first surface habitat delivery to Artemis VII. Base camp elements like a surface habitat are part of the broader concept, but the exact sequencing by mission number is not publicly baselined. The crew will be tasked with landing near the pre-positioned hardware, deploying the habitat, and bringing its core life support systems online. This mission is less about exploration and more about construction, establishing the first true foothold for a long-term human presence on the Moon. Artemis VIII. NASA has not published an official description that Artemis VIII is the first mission to use local resources. In situ resource use is a long-term Artemis goal, but it isn't tied to a specific numbered flight in public documents. This crew will be the first to inhabit the surface habitat for an extended period, and their key objective will be to deploy and test the first in situ resource utilization pilot plant. This groundbreaking experiment will be the first attempt to extract resources, such as oxygen and water, from the lunar regolith. A successful demonstration will be a game-changer, proving that future missions can be sustained with local resources, dramatically reducing their reliance on Earth. Artemis IX. This mission will deliver the next generation of surface mobility and dramatically expand humanity's exploration range on the Moon. NASA has discussed pressurized rovers as part of future sustained lunar exploration concepts, but it has not publicly assigned first pressurized rover delivery to Artemis IX in an official mission description. Unlike the open-air LTV, this will be a large enclosed vehicle that serves as a mobile habitat and laboratory, allowing a crew of 2 to undertake multi-week-long scientific journeys across the lunar surface. This vehicle will enable exploration of distant craters and geological features that are hundreds of kilometers away from the base camp. Even if the exact rover debut isn't locked to this mission number, the broader direction is clear: longer traverses, wider science reach, and crews spending far more time away from a single landing site. Artemis X. NASA's long-term strategy is to use Artemis to learn how to live and work on another world as preparation for Mars, but there is no official public mission description defining Artemis X as a Mars dress rehearsal. With the gateway fully assembled, the base camp operational, and both pressurized and unpressurized rovers available, the crew of Artemis X will conduct the longest surface stay to date, potentially lasting for several months. Later Artemis missions are intended to increase capability and experience for long-duration exploration, but NASA has not published a definitive, mission-numbered plan describing Artemis X with that level of detail. Thanks for watching. Which part of Artemis matters more to you? Landing astronauts again, or building long-term infrastructure? Let me know your thoughts in the comments. Also, please remember to like and subscribe if you enjoyed this video.